Now, our next speaker is involved in a lot of research, and his research groups, they focus on stuff like cyber-physical products, robotics rather, information models, also digital twins, and IT, OT security. And he also looks at things including agentic AI, embodied AI, all in combination with knowledge-based deterministic approaches. So please now welcome on stage from the Karlsruhe Institute of Technology, also KIT, but not KIT, keep it together, as we heard before. He's the head of the chair for Networked Secure Automation Technology, Professor Mike Barth. Welcome, Mike.
Thank you. Very good.
Hello, Mr. Esthaven. Nice to see you again. Initiating.
Für uns in Karlsruhe geht es wieder um die Sicherheit.
Beste Grüße nach Karlsruhe.
"200 years KIT celebrating this year, and in my opinion, there's no better way to show you our past. And today I'm here, and thanks for having me, for showing you our today and our future in robotics, of course. So this is the IRS team, part of my institute, part of the Institute of Control Systems, together with the colleagues from me. And I would like to start this presentation with a deeper look into our research areas in robotics. For, as most of you, of course, we are dealing with human-machine collaboration, but not only in production, but many, many other things, like, for example, caretaking, as you will see at the end of the presentation. But we are also dealing with deep dive control technologies, for example, when it comes to machine-machine coupling, gathering a higher stiffness, for example, for welding and grinding operations in different areas of industry. But it's not only about production, it's about helping people doing their daily jobs. For example, those two guys, we have several projects together with fighter agencies. You see this small shadow moving, which is a drone, an indoor drone, navigating through harnessed environments and locating the, for example, people that need to be rescued out of there, helping, like I said, people to do their job. We also do, of course, autonomous driving. This is a video.
Dann wohl der Präsident des Karlsruher Instituts für Technologie. Dieser Meinung ist auch Jan Esthaven.
This is a video that we had starting our new president that you saw on the first starting video, moving around in unknown environments. So it's autonomous driving inside production, for example. And it's not only on Earth, but also in space. This is Linus. Linus should be, oh yeah, hi Linus, PhD student of mine. So Linus was together with a team of the DLR at the Etna, getting this tiny little robot who is presented to be part of a space mission going to Mars. And of course, as you see, it's about autonomous driving of that robot, but not only autonomous, but astronauts, they always want to be in the cockpit, and they want also to control the system. So we gave them, in a robotic way, a method to autonomously drive, but also to control it in a symbiotic way, which was really cool at the Etna in Italy because it looks like Mars, obviously. So this is also loose. I talk a lot about research, and we are not only doing research. We have 22,000 students, not all dealing with robots, but most of them. And this is what we do in one of our new labs. So we construct a robot from the scratch, from the green field, 3D print it, get all the electricals in there, get all the software architectures in there, and of course, I tried to zoom in, but it doesn't fit, so it's about open architecture, and open architecture are a focus of this presentation today. And this is about learning our next generation, maybe the sons and daughters of you also studying at a university. It's really not presenting nice-looking UIs, it's getting them into a deep dive into every bit and piece of a single robot. This is what we do at an excellent level. And this is on one of the outcomes. It's a project, one of our master students, now a PhD student of mine, who constructed this soft robot from the scratch. Fully 3D printed, fully flexible, following a continuous movement here, and, which is also a big thing in my presentation today, it's fully modular. Maybe you see the colors, so we have black, red, and blue, and those are all fully identical modules, talking directly to each other and then fulfill the specific task, for example, moving the TCP to a certain point by coordinating each other. So modules is a big part, as you know, in industry today. I promise this is the only slide with having equations on it, but I get fired if I don't have slides with equations on it. So here we have what we need to take care of course, when it comes to control technologies, as most of you do, is having the set of equations to get meaningful movement. Here it's piecewise constant curvature, but what I want to talk about today is how to get those things, and there are many, many more of information model, into common information models that then can be combined during our engineering, as Bernd Kuhlenkötter already mentioned, to integrate it into an ecosystem. And this is what we are dealing today, so it's the engineering of robotic systems. And as you see here, coming to our industry partners is more or less a set of components brought together to sub-modules, and those sub-modules, like for example the robot manipulator with a gripper on it, is then forming, together with an AGV to get it mobile, is then forming a mobile and autonomous production unit. And this is what we see also in discrete manufacturing, but also in process manufacturing, that they are production units, and we as robotic engineers, we are the aliens introducing or step in this environment, and then we need to take care about the standards that are already implemented there, and those standards then need to be part of what we are doing. So we have those classical engineering variants as we all know it, and it's still day by day. As we saw in many presentations today, we have the manufacturers, we have the systems integrator putting all of the stuff together and then get it running for the owner-operators. But SRCI is a big topic of today. It's also a big topic at my institute in several research projects. So we get the SRCI standard on our PLCs, making the PLC a center of robot control, which is a cool thing. And in my institute, Linus, for example, we developed the Unified Robot Integration Package, which is on a lower TRL level than SRCI. This is why we are doing research. But this package is not only about controlling the robot. This package integrates safety, it integrates security, it integrates human-machine collaboration and many, many things more to be part of a production module that needs to be integrated in an orchestrating system. So have you ever thought about certificates on a robot gripper, how to update them? This is part of such an integration package, which is not a single and isolated thing beside those variants. It can integrate them, of course. But on a lower TRL level, we are working on that. And now going into the fragments, the aspects that such an integration model needs is, for example, when we go into process industries, like we heard it this morning, which I find very, very good example. Process industries is all about recipes, is all about getting state after state done in their production facilities. So we need to have a clear idea of our robotic module and its states, and this is where we integrate Herald state charts based on ISA 88, for example, and then we need to have an idea of how to model our functions of the parts of the robotic system inside a module. And here's just an example. Why is this very important? What you see here is, from an information point of view, nothing new. It's automation ML. Some of you might know that from discrete automation in the automotive industry. And we take automation ML as one of the bases, but not the only, to model what we need in terms of function. So, for example, you see here an articulated robot that has the move joint function and has a joint trajectory controller. I'm always stumbling about that, with a ROS action interface, and this can be exchanged into memory variants. And they are, of course, part of our digital twin. This is just a video showing what the experts in process industries need to know about the system. They don't need to know about what exactly is the robot doing in the function. They need to know, hey, what are the states of your robot, and can we control those states in terms of recipes? And therefore, let me have a quicker look into robots in process industries, which was introduced that morning. And I really promise you, the process industry, is someone from process industry here today? BASF, Böhringer? Not yet, so I'm going to talk about that. Process industry is very, very, very interested in getting robots into their facilities, like the problems that we heard that morning. It's not only about the women and men working in there. This is one of the things, but it's not the only one. The other thing is the rising complexity. It's not about the huge world facilities that are running 24/7, days after days. It's about pharmaceutical that changes their production day by day, because they need to have highly, highly intensive medicals for you, and you. And this needs a change in their production configuration. And therefore, I would like to introduce you into a quick look to our RAMP project, Robot Assistant Modular Pipeless Production. We are doing together with our partners from Siemens, from SEW Eurodrive, Sartorius, Boehringer Ingelheim in their production facilities, and the Ruhr-Universität in Bochum. And here you see what it's all about. Typical pharmaceutical production is like the modular production plant at our partners Siemens in Karlsruhe. You see here it's about different modules forming a pharmaceutical process. And here, just a few kilometers away, the modular production at the IRS. And those modules, of course, they can be connected, for example, using standards from the process industries. Today, we had it on the slide, the modular type package is one of the most important ones. And what we do now is integrating our mobile and modular robotic system to deal with those modules, because those modules cannot be static anymore, and they cannot be human lifted. It's all about reconfiguring this by mobile robot. And this takes a lot of heavy tasks that we need to solve. For example, there's one thing, it's about aseptic welding. It's about combining things that, between those different modules that our robots need to do. And this is only one thing that we need to take care, besides just lifting the complete modules and taking it to another part of the building and then reassembling it again and again and again. And there are so many great PhD students, so many great researchers working on that project. I just put some of the examples here. We have Tony. Tony's here. Hi, Tony. Working at Siemens in Karlsruhe as a research engineer, educated at the KIT. And he is doing integrating those processes on a PLC using the MTP as a standard that needs to be followed, not being an alien, as I said, in the robotic context, and integrated into the standard process orchestration layers that most of the pharmaceutical, but also most of the chemical industry vendors have. So we are not changing the environment up there. There's no chance for us to do this. They would stop their production immediately. And under the hood, on the southbound, he's using SRCI. as a very promising thing, integrated into PLC, but not only as being open. We can have a ROS PLC interface, for example, to advanced skills. And those advanced skills are also needed in our project. So here we have Thomas Becker, our partners from the Ruhr-Universität, and he is dealing with those pipes, the pipe connection and the hoses, all flexible. They are made basically out of rubber. And he needs to detect it, and he needs to manage it with different kinds of grippers, not damaging it. And this is a highly flexible work that he's doing together, of course, with neural networks for object recognition. And of course, we talked about safety and security today. Here we have our safety guy, Jan Riffel. What is he doing? Well, we already had in Bernd's presentation today, we already had the driving robots through a man-filled production scenario. And in pharmaceuticals, it's even more. It's not only driving the robots to one floor. We need them to change many, many floors because their production facilities are built like normal buildings with lifts in between. And he is using, for example, game theory to get the movement of the robot in a much quicker way done to save human existing corporations. And last but not least, we have an extension of the whole setup. As we are dealing with chemical and pharmaceutical, it's about getting all the things in the lab, not only in the production. And in the lab, so many things are changing. And here, as we already heard today, you see the great elements that we have now together with MCP, combining LLMs with graph-based theories where we put our knowledge in. And there's so many knowledge bases that we have in the chemical industries to get one thing and one thing only, a deterministic behavior. And this is what he's dealing all about. So again, it's AI in Robotics.
Das wird noch Jahre dauern. Gut möglich, dass am Ende ganz andere Modelle mit den Püttlinger Daten gefüttert werden. Aber Holly leistet dafür wichtige Pionierarbeit.
And it's not only about production. So, any sufficiently advanced technology is indistinguishable from magic. So let us together continue doing magic. Thank you. Thank you.
Presentation, Mike. Thank you so much.
Thank you.
I can literally feel that you're living for what you're presenting and what you're developing.
I do.
That's so great to see. And I have the feeling that if I had you as a professor, I would have been in tech as well, because that's really motivating. So I went in communication. That was the only thing I could do.
There's still a chance for you.
I'm afraid no. But are there any questions from the audience to this professor on site who even brought some students here? So it's Tony, I wrote down here, joined you. Linus was on the presentation. So you have a close relation to your students. That's great. Also that you take them on excursions to really work with the things they are developing with customers and testing it. Yes. That's super. Questions? Because if not, I have some. First of all do you see a change in the level of expertise your students bring to the table? I mean, they grow up with iPads, literally knowing things and working with tech and with AI. Mm-hmm. So how do you include that in your studies, in your work, in the developments?
Mm-hmm. University studies more or less have been all about theory, getting the theory done, like the equations that I have. Today, it's not only theory. Today, it's a lot of practical work. And therefore, we need those guys to visit our laboratories to get the robots done in a meaningful manner, to have that sort of experience before they start in their job. Because in times of AI, like most of us, they already wrote their bachelor thesis, and you had an introduction, and you had a state of the art. Is this still the way we should do it today? Like AI is doing that for us. So we need to start at the method, at the thing where they develop their concepts, and the concepts can be developed in a practical environment.
Talking about practical things, that's also what I realized, that everybody is just depending on the AI being delivered and nobody really puts their hands on technologies anymore. That's what your students still do, that they are practical engineers and not just theoretical engineers.
Exactly.
Okay, the next thing is, now people might think, well, Institute, they got the money, they have all the latest technologies. And also here, how do you keep up with the speed of change of technologies? You need new systems, new programs, new partners. How does that work?
That works with international cooperation. In times of when you and I read in the newspapers or watch the news or watch your feed, when every country is sort of isolating, doing their own thing, what we need to do in research and what you need to do is keep up those international connections. They are the most important thing for getting such big things like robotics and AI together on the street. And this is what we need to work together. And of course, we as a university, we are not only sitting in our dark shelters, but we work together with you guys in more close than ever before. Like I get always asked, hey, in such hard times, the first thing that you cut off is costs for universities, like your university corporation. This is not the case, not at all. We have such tremendously close university cooperations than never before. Like, for example, with Siemens. In former times, the people in the companies, they have the cooperations with university, but it's sort of beside the day-by-day work. Today, it is a clear focus on what are you doing, what is next thing. So it's very innovative today, and this is what brings us together here.
And you might get, with all the changes in the US, you might get a lot of new colleagues bringing into the international spirit.
They are already
and
here. But not only, yes, colleagues, of course, but think about the thousands of young people that are now coming to Germany, to Europe, to study here in their master. This is a great chance, not only for us as universities, a great chance for you to get the best people in the world because they are already living here, doing their studies. It's great. Thank you, Mr. Trump. Yeah.
All right. Thank you, Mike. Great information. And for sure, there will be a fan crowd hanging out at your table during lunch break now. Keep up the good spirit and the motivation. Once more, a big round of applause.
Thank you.